our project goals, I want to introduce you our goals we set at the beginning. First goal was to create a replica of the fischertechnik APS in the software Unity. So the second goal was to create a real-time visualization of the physical system. That means that the digital twin we created in Unity does the same things as the real system. So if the vacuum unit moves, then our digital twin in this visualization also moves. The third goal was the implementation of the digital twin as a WebGL application. You can see this WebGL application here in this background. And with this WebGL application, it's possible to access it from all over the world. Yeah. And the fourth goal was to develop a bidirectional communication between the real system and the simulation. Yeah, that basically means that we receive signals from the real from the PLC, but we can also send signals to the PLC from our digital twin. And the last one was to create an intuitive user interface for monitoring and controlling. So like here we can lock the camera and these things. Yeah. Okay. Now I want to give you a short introduction into the fischertechnik APS. There are several modules. First, the DPS, the drop and pick station. This contains PLC and also TXT controller. The TXT controller controls the 6-axis robot, and the PLC is just for the basic procedure, like I put in a part and then the robot moves, and yeah, like the step chain, which steps are needed to move it into the vehicle. Next station is the IIQS, the quality station with artificial intelligence. There we also have a PLC and a TXT controller. At this time the TXT controller is for controlling the camera. The camera takes a picture from the part, and then it evaluates if the part is good or bad. The bad part is something like that. If it has a crack on the surface, then this camera will recognize it and move it out. And then the vehicle gets another part out of the eBay warehouse. Then the next module is the mill station. It's this one. It only has a PLC for the procedure, like picking it and yeah, to do the procedure, the process to mill it. Nothing special. As I said, it's just pick, drop, and then we have the HBV, the high bay warehouse. So every part which we put into the TPS, the drop and pick station, gets transported first into the high bay warehouse, and if needed, the user can order a part, and then it gets procedured and processed. The next station I want to talk about is the drill station. It's basically the same as the mill station. So the PLC interface and all the stuff is almost the same. Yeah, nothing special, as I said. Just pick, processing, and then drop it into the vehicle. The last module is the FTS, the driverless transport system. It's controlled by a TXT controller. It's for controlling the movement, like the wheels and the camera. It's mounted at the rear end. It has a capacity of transporting 3 parts at the same time. Maybe it's possible to move both FTS at the same time. That we never tested. Maybe in future it's possible to, as I said, to move both at the same time. We only have one here inside the visualization, but as I said, maybe at some point in the future it's possible. Okay. Then I want to talk about the structure of communication. At the bottom of this picture, I'm not sure if you can all see it, but yeah, there are the modules. As you can see, the PLCs are connected via OPC UA to the Raspberry Pi. It's here at the end, is the Raspberry Pi. And TXT controllers, like from the camera and the robot, they are connected via MQTT to the Raspberry Pi. So the Raspberry Pi is basically the heart of the system and the main control unit. Yeah. It's also here, you can see as a picture, there is PC tablet at the right side. So this is this PC. It's providing a dashboard where we can control the facility, like ordering something, or yeah, maybe can open the dashboard later. Yeah. Okay, then I want to talk about the Raspberry Pi and its tasks. One task is that it serves as an MQTT broker. That means it receives, manages, and sends all the signals to the modules. As I said, it's the central control unit. Yeah, that means if I order something, the Raspberry Pi will decide which module has to do what. Like if the FTS has to move forward, and yeah, this the control unit sends to all the modules. Next thing is, as I said, it provides a dashboard to control and calibrate some stuff. So you can do all the settings in this dashboard. And last, it provides a IoT gateway, which means that it does some data filtering and also data preprocessing to limit data flow. Okay. Then I want to talk about PLC. As you can see, we have output and input signals. Output signals are the signals which the PLC sends to the actors, like to the vacuum unit that it has to move upwards, downwards. Yeah, the signals are more at the bottom, like the Q signals. It's, as I said, it's like move the belt or move vacuum unit. We need the signals also in our digital twin, because we need to react to the same signals. So if the PLC sends to the belt or to the motor of the belt that it has to move, then our digital twin has also to move. And you can do a check mark. As you can see, the blue check marks on the right side. That means that the PLC sends the signal to the Raspberry Pi, and therefore we can work with the signals. Then there are input signals. These are signals like light barriers, sensors, switches. Like if I put here a part inside, then the PLC will detect this. And we need the same signal, because then we know that we have to show this also part in this position. Yeah, like then we would see here that the part will pop up right there. Yeah. Here then we have internal variables from function blocks or step chains. These are mostly current status, like if the PLC is idled or if the pick process is active. Then commands like command pick and calibration data. These signals were already sent. Also the communication I showed you before. The signals were also already sent to the Raspberry Pi. So yeah, we just added the input and output signals for our digital twin. So maybe in future, if we need to include some data to the digital twin, we can also work with these signals. So basically you can read all the variables out of this interface. Yeah. Okay, yeah, this was my part. Now Max will